You've probably seen this. A function, a slope, a derivative. And among all rules of derivatives, one is going to be the main star of this episode, the product rule. The thing where you differentiate one function and freeze the other, then you switch and add the terms together. If you've ventured into vector analysis, you might have also seen this applied to dot product and even cross product. And at some point, a series of questions will arise. How do we know that an operation is going to respect the product rule? What properties guarantee it? What do we exactly expect from a quote-unquote product? If we look at them closely enough, ordinary real product, dot product, cross product, and really many other types of products share a common property. They distribute over some type of addition. And coincidentally, addition appears on the product rule. This suggests that being distributive over addition is among one of the required properties. Let's see if it can get us any closer to the product rule. We first write down the definition of derivative as limit of difference quotient. We pull out the usual move to rearrange the expression, expanding the invisible zero. Apply a property of limit. Make use of the operation's distributivity over addition. Apply another property of limit. Then finally evaluate each limit and recognize derivatives. Turns out, an operation being distributive over addition is enough to give us the product rule. And we didn't even insist on any particular domains when we started. We never said it had to be on the real numbers. We simply demanded that it be distributive of addition. So long as an algebraic structure has an operation that distributes of addition and its definition of derivative as limit is similar to the one we've written down here, then the product rule stands all the same. Ordinary real multiplication, complex multiplication, matrix multiplication, dot product, cross product, outer product, and even more. And as usual, we can generalize this result easily to partial derivatives. It goes without saying that I've hid some implicit assumptions under the hood. Okay, let's pretend we didn't see that one. Sometimes the product rule comes out naturally, a logical consequence, so to speak, from how the derivative is built. At other times, we flip the script. We ask that derivatives obey the product rule and build our idea of differentiation around that. Or sometimes, we even ask the derivatives not to obey the product rule exactly, but its graded fashion. Differential geometry is especially guilty of this. But hey, it's not like we can talk about just everything given the time and space constraints, so I'll stop here for now. I'll see you again sometime, and this concludes the first episode of Archive of Wandering Thoughts, Mathematics Edition, extending the product rule of derivatives beyond ordinary multiplication.